So thanks again everybody for coming along. I'm not going to take up too much of your time because I'm sure you've already downloaded 3.5 and you know everything, so this is a complete waste of time. But nonetheless, I'll get started. So version 3.5, it all started back in 2016, May 2016 after KXCon. And we have a lot of ideas, a lot of them come from the customers. In fact, most, if not all of them, come from the customers. And we throw a lot of them in the pot, so there's lots of things that we try out, and lots of things that we throw out as well. So we just thought, whoop. And so that was just a funny joke slide about the debugger. Then the next slide was a picture of a bug running away. Trying to do this on the fly here. And the next slide is actually talking about the debugger. So these are just words. I'll be actually putting these slides up on the meetup as well, so there's nothing proprietary in here. So yeah, the debugger, that's the big thing that's coming in version 3.5. And that's already here. It's, you know, obviously there was a debugger before if you didn't know. But I think it's a little bit more enhanced than what we had there. So it started off with Pierre back in the office in London. And I think I was about the second or third person to see the first cut of it back in, I think it was July in the London office, so it was pretty interesting seeing it for the first time. So basically it's extended to include the backtrace of the call stack, so you can actually go up and down through the call stack now. It includes the current line executed, the file name, and the line and character offset, and then also an indicator pointing to the failed operator. Okay? So then the debugger continued. So the functionality, the caret basically just points out the actual failed operator. So when you see an error, you'll see a caret, and then that will show the actual problem. The backtick shows to browse from above. So if you're going down the stack, you just use backtick, hit enter, and backtick. Yeah, I don't think it's a power issue. It's actually the projector itself. So, sorry. Dot then goes the other way. It goes down the call stack. So I just use backtick and dot to go up and down the call stack. Then there's .z.ex. So once you're inside the failing primitive, or once you're inside the debugger, that shows the failing primitive. So similar to what you had before if you look through the actual argument list. And then .z.ey, sorry, I see .z, European. Yeah. .z.ey is the actual argument list. So that's, you know, pretty relevant. And then there's three functions for formatting and printing the stack trace. So you've got .q.bt, which actually prints out the stack trace. And then you've got .q.sbt. It was actually previously called .pbt in some of the earlier versions of 3.5, the beta versions. So that's for formatting the stack trace, so it gives it a more kind of user-friendly format. And then there's another new function as well called .q.trp. So this is uppercase Q, by the way, those three functions. And .q.trp is basically .q.trap is similar to the predicted evaluation. So except that the G attribute, or the third output, it actually prints out a backtrace as well. So it's basically a more modified version of the predicted evaluation. So here's an example of it here. So there's a simple script where the first line is a comment, and then the second line is a function which literally just adds 1 and x, the input parameter. Trying to do my best here. So then this is the output. If I load that test.q, and if I call that function passing in symbol a, so obviously I'm adding 1 plus a, so traditionally you would just get a type error and be told to get bent basically. So now we give you a bit more information. You see that you still get that friendly type error, but then below you'll see that you'll get the actual list of the file names. So you'll see it's user/fintan/test.q, and then you'll see 2, which indicates the actual line number of the actual function that caused the error. And then you'll see that there's a caret here underneath the plus, which is the operator that actually failed. Okay? So that's kind of the basis of the debugger. So we encourage everybody to go out and create many, many bugs. So you can find the bugs in the debugger. It's kind of it's getting very meta here at the moment, but I know it's kind of like an episode of Community. But so yeah, we encourage people to try the debugger. We've put a lot of work into it. We've got a few plans in 3.6 coming down the line to increase it again, like put in breakpoints and do step over, step through. Those aren't in there yet, but we've got mechanisms in place where we'll be doing that. So hopefully in 3.6 in X months or years time. So it's still a fairly first cut version, but I think we've got pretty good feedback from the people using the 3.5 test version, so we're getting there. And the next one then is a picture. It's basically a cloud with 3 brains connected to it. And this is the concurrent memory allocator. So you can see I spent a lot of time searching images. And so what the concurrent memory allocator is basically if you're running KDB Plus in multi-threaded mode, previously in the past you had a big overhead of serialization and deserialization going between the slave threads and the main thread. So now that's basically gone. So we've worked out how to fix the heap and the local heaps talking to the main thread heap. So that's gone. So that basically means you can, as Simon Garland told me earlier in the week, you can write stupid queries using Q now, which means basically where you're returning a lot of data, as opposed to traditionally we'd recommend, you do large aggregations. So in the slave threads, you do the aggregations and then you return just a small amount of information back to the main thread. But now you can write the so-called stupid query, where you're just actually doing maybe something like a data dump. Because before that was actually taking a lot of time because you had a huge serialization, deserialization overhead. And so that should help a lot. And so as I said, it has negligible effect on pretty large aggregations because you're just getting rid of the serialization overhead for just a small amount of data. But obviously for a big, if you're doing bulk data dumps or something like that, this helps a lot. And also as well, it works with shared libraries. So it should actually benefit, I think, PyQ, if I'm not mistaken, Alex. So if you're working with shared libraries that are talking directly to KDB+, you don't have that serialization, deserialization overhead. So it helps with that again. So that's actually quite a big improvement. So for very large queries, we did some testing. So for like big, say like select from quote, that type of query where every SA wants to kill you. Why is my memory going so high in my swap space and kicking out? So that's the concurrent memory allocator, and those queries were getting pretty good performance results. And the next one is basically shared sockets. So there's an electricity. It's kind of ironic now, given I've had this problem. So basically, so it's called socket sharding is the technical name for it. It's an operating system thing, or shared ports. So there's basically two flags. The flag for Linux and OS X is SO_reuse port. And if you have the misfortune of working on Windows, it's called SO_reuse address or reuse ADD/OR. So basically what it means is now that you can have more than one KDB Plus process listening on the same port number. So previously in the past you could just have one port number and that could be listened to. So now you can do it on multiple port numbers. Excuse me. But basically what it means is that the connections are determined by the kernel and not by KDB Plus. So that's just one big thing to know. That's a kind of a disclaimer right there. Don't blame us, blame the kernel. And there's two ways to do it. Obviously, you can do it at the command line. So to call it now, you just put, so if you're calling it like -p, say 5001 at the command line, you now just do -p and then you do RP, 5001 or 5010. So you just put RP in front of it, and then similarly when you're inside the console, instead of doing /p port number, you just do /p and then RP, port number. We tried to think of a few different ways of doing it that wouldn't break, so that was kind of the most sensible one. So the one thing is that it's not used for, or it doesn't support the Unix domain sockets yet. So if you're using Unix domain sockets, this won't help you out. It's only for doing TCP/IP. That's something that we'll probably look into for 3.6 as well. And then the use case basically is for maybe something like coarse load balancer, where maybe you have several historical databases and listening on the same port. So maybe if one goes down, you will still have to reconnect, but it will actually just maybe connect. So if something's getting clobbered by another connection, you can maybe reroute to another connection. But it's all done by the operating system, so it's kind of that disclaimer. And also as well, it can be very good for high availability and failover. So if a process does go down, you can just reconnect easily on the same host and port. So that's that nice piece. So now the next one is this faster sort. And this is a very poor image. I couldn't really get a good image for sorting. So this is an assembly line showing people sorting what look like beans. So yeah, the faster sort. So KDB Plus internally it uses a hybrid sort. So the sort algorithm that is used is determined by the data type, the size, and the domain. So what we've done now is we've significantly improved the performance of the sort algorithm for certain distributions, especially different distributions that are very wide. So if you have a lot of nulls and a lot of very wide figures, it's very, very fast. So I actually have an example here, but the same example will be on the wiki page, so you don't need to read the very obscure code base. So obviously this is very good for things like doing a fast end of day write down now. So if you're reordering by your symbol rather than by time, this will help that significantly. So you'll get a pretty big performance gain for the fast sort and anything to do with sorting in general. And then we've also got faster search. So this is 3 people looking out of telescopes and standing on briefcases in salt mines. So basically, bin and find, which is the question mark, and also distinct, have all been improved significantly. So obviously, as a result of that, then basically all of the joins are sped up because they use these functions under the hood. And for many loads, we've seen it up to 100 times performance, and that's for very certain data loads. And it's also very fast, particularly for joining multiple columns together. So once again, there's examples on the code.kx as well for that. And then this is basically a picture, and this sign on the road is in the cycle lane, and it says give cyclists space. And you can see that it's actually the cycle lane here. So this is basically talking about the few but relatively ineffectual and non-umbrically compatibles. So the first one is we have a new keyword called UJF, which basically is the union join functionality from 2.x, which I believe gets it from the left-hand side. So that's just basically just a new keyword, UJF. And then the constant limits in the lambdas is now reduced from 96 to 95. So hopefully you won't get affected by that. But if you do, rewrite your code, more modular. So that's nice. So that's basically, we needed that for the debugger component. So if you're, complaining why my constants are now limited to 95, and that's why you have a debugger. So there you go. And now Unix domain sockets use abstract namespaces. So previously until now, they would open a temporary file in /tmp, but that was actually causing some issues for customers. So we've gotten rid of that, and now that's running in an abstract namespace. And then actually for the tokenizer now, so if you're doing -4 bang, we've stripped, or we're no longer stripping out the comments. So previously before we'd actually strip out the comments, so that's now gotten rid of, and now we actually keep the comments in because people were looking for them for like IDE tools and returning the front ends, etc. So comments are actually available within the tokenizer. And now if you do value on a function, so the way if you did value on a function, it would give you information like bytecode, etc. So now it returns more information. It's basically all the same information that goes in the debugger. So the source file it came from, the namespace it came from, the name of the function, the source code, and the constants, etc., etc. So it just gives you more information. But we recommend maybe not making too many dependencies on that, because that's subject to change, especially with regards to any enhancements we will make to the debugger. So I think that's all I had, apart from, if you go to code.kx.com, probably in the last month and a half or 2 months, you'll probably be cursing us, because it hasn't been working too well, but that's because we've been migrating it over to the newest version of code.kx, which officially became live today. So now it's a significant rewrite from start to finish. We hired somebody who's written lots of technical documentation in the past and actually has worked in the KX community. So everything has been rewritten from start to finish. I think it was something that was 1,500 or 1,600 pages. So it's quite a lot, and it's taken a complete rewrite. It's made a lot better organized, and it's finally up today. So for those of you who were using it over the last few weeks, the search function actually works now and works way better than it did before. And so that's a significant enhancement. And so we recommend to try it out, and it's all actually linked back to GitHub as well. So now you can actually fork the entire repository and create your own version. So that's pretty cool as well. And I think that's about it from me. And I think if anybody wants to go to drinks, there's Victoria here wearing the red sweater who's going to be taking everybody out to drinks. But if you've got any questions, feel free to ask me afterwards.